So today we are going to continue with our lesson from yesterday, but we're gonna add another lesson to it. So this is where we stopped at yesterday. We were solving, or we were changing between radical and rational forms of exponents, right? Remember that, just as a recall from yesterday, if I had a power of 1 over n, that's the same thing as writing the nth root of a. And we talked about yesterday that if I have a m over n, that's the same thing as the nth root of a to the power of m. So whatever is in the denominator goes in the root. Whatever is in the numerator goes as an exponent for your base. Now, what if I have x to the power of 4 is 16? So I know my exponent. What I don't know is my base. How can I solve for that base? Rearrange the formula or rearrange the equation. How would you do that?
Take exponent to the other side.
And what does it become when you do it?
It becomes a root.
A root. Okay. All right. So basically what Maha is saying is that x to the power of 4 equals 16, right? I need to do the opposite operation of a power. What's the opposite operation of a power? A root. A root. The opposite operation of a power is a root. So to get rid of that power here, I need to take the fourth root. Don't we? Right? We know that if we had x squared, to get rid of the square, we square rooted, no? If we have a power of 4, to get rid of that power of 4, we have to do the fourth root because they're opposite operation. Right? So that here, it gets rid of the power of 4 and leaves me with the fourth root of 16, which is 2. It's not a square root. Okay? So whenever you're solving for the base, remember that you are doing the opposite operation. Now this was an easy one, no? How about the second one?
You would have to switch over the power of 3 over 2 to be 3 over 2 root of negative 27.
So you mean the root of 3 over 2? Is that what you're trying to say?
Yeah.
Cube root.
So I see what you're saying, and it could work, but we don't usually do a 3 over 2 root, okay? We don't use a fraction as our root, okay? So there is a different way that we have to approach this, okay? So, and then part of it is gonna be the root, but we have to split that exponent into two different things.
Wouldn't it just be square root of x3?
So you wanna write this as a square root of x cubed.
Yeah.
Okay, so let's do that, okay? It's easier to visualize for you guys because you are used to the square root. It's easier for you to see it, okay? So what Eric is saying is that right now, I just want to write it in a different way. I just want to write it in the radical format, okay? Is it easier for you right now to solve? So what would you do right now to isolate for that x? What's the first thing you want to get rid of?
Square root.
The square root. And how do you get rid of a square root?
You square it.
You square. The opposite of square is square root. The opposite of square root is square, right? They're opposite of each other. So right now, to get rid of that square root, what I want to do is I want to square both sides, yes? So I just want to recap something before I move on. Do you guys understand what happened in the first step? I just rewrote it in a different way. You see how we were doing the rewriting in this case? So all what we did is we rewrote it in a radical format. Okay? Are we okay with this, everyone? Now, to get rid of the square root, we have to square because the opposite of square root is square. So I'm starting to get rid of stuff. So square both sides. So this way you can get rid of the square root. Okay. So you have x cubed equals, what's negative 27 squared?
729.
Maya,
Yes.
why are we not putting the negative 27 in square root? Is it because of what you said yesterday? When we put the
Why would I square root it though?
when we put the x 3/2 in square root,
No, but I did not do anything for this. I just rewrote it. I'm going to add a page here. Just one second. So I have this, right? All what I did here is I rewrote it. I didn't change anything. I just wrote it in a different way. Okay? So what I did for the first step is this. I wrote it in a radical format, right? Which is a 2 goes here, which I don't write it because that's my norm, right? I don't write that 2 because that's my norm, right? And then I put the x cubed here. So my first step, I didn't do anything. I didn't solve, I didn't isolate, I didn't do anything. I just rewrote.
It's the same?
It's the same.
thing, yeah.
It's the same. But which one is easier for you
Okay.
to solve? If I ask you to solve this for me, or to isolate for x, are you going to be able to do it? But if I show you this, are you going to be able to isolate?
Yes.
It's easier for you because you're used to this, right? So when you see this, you know that to get rid of that square root, I have to square, right? Because we are used to this. And this is when I have to do it to both sides.
Okay.
Okay? So let's go. Are we okay with this right now? Okay. So I got rid of the square. Now I have x cubed equal to 729. What's the opposite of cube? Cube root. So now to get rid of the cube, I have to cube root both sides. So that would leave me with x equals to, what's cube root of 729?
9.
9. So I'm going to take you back to that page. So I solved for x, no? I have the answer. Just going to take you to that next page. And I'm going to, let's see what we did here, okay? So first, to get rid of the over 2, right? First we squared, then we cube rooted, no? Okay. So first thing we squared, then we cube rooted. So if I'm squaring and I'm cube rooting, what power is that? So if I have this, if I'm doing this, what was my answer, negative 27? Okay. So what I did for the negative 27 is I squared it, then I cube rooted, right? This is what I did to it. Write this in a rational form for me. How would I write this as a rational form? 2 divided by 3. Okay? So I started with 3 divided by 2 to isolate. I rose it to the power of 2 over 3. No?
So flip is an easier method
Yeah.
than all that.
So if I want to get rid of the 3 over 2, so if I go back to my question and I have this, right? This is my question. This is where I started, right? If I want to isolate this in one step,
I can multiply by 2 over 3.
I can raise it to the power of 2 over 3. If I raise both sides to the power of 2 over 3, what happens is this and this cancel each other, this and this cancel each other, so you'll be left with x equals 2, and that's going to be 9.
I just showed you.
because you have to understand why. If you don't understand why, right?
I like
Which one better?
Oh my goodness.
I like this one better.
The easy one?
Yeah.
But would you have understood it if I did not show you, like you know this, right? But technically what you have done, in one step, if you're looking at it, you're raising it to the power of 2 over 3. Okay? So anytime you have a power that's a fraction, to get rid of that power of fraction, you raise it to the power of the inverse.
Okay, that's all I want to hear. Yeah. Maya, let's finish copying the other side.
Okay. There's too many things written here. I don't know how you guys are going to understand this. Sorry. I know I go like different places when I don't have that phone.
But,
Yes.
how are we, writing this in the calculators? Because I'm getting errors every time
What, for negative 27 to the power of 2 over 3?
yeah.
Okay, so in the calculator, let me write that down here. Number one, you have to put your bracket. You're going to put negative 27, close bracket. You're going to put your power button, open another bracket, 2 divided by 3, close bracket.
Oh, I still got it there.
Let me see why. Because when you put the negative, that gives you right away a bracket, okay?
Oh,
Still gives you an error. Do you guys, does anyone, does it give you an error? You call my method? See, it works if it's